Continuing on with section 6 of chapter 5, solving quadratic equations by square root property, and then later the quadratic formula. Now, in this lesson, we're going to be pulling in a lot of things we just had, including the radicals. Two objectives, rather short. Let's go on to get some background. Now, we had used factoring as a method to solve quadratic equations in an earlier section. We're now going to use what is called the square root property. So for background, this is the title of this in your notes. Now, they give us an example here that if we had x squared, and we say that equals 5, and we want to solve for x, we could say the square root of x squared, which would be x, and then the square root of the other side, which would then be the square root of 5. Now, interestingly, remember we said that with a quadratic equation, we should get two solutions. Here we're only getting one. Now, we work around that by saying, in a sense, it's going to be in the future now, from now on. Whenever you take the square root of something on one side, you're going to take plus or minus the square root on the other. Let's go to the whiteboard and I'll show you what we mean here. And we'll clear this up. So if we had x squared equals 4, if we were going to use that by the traditional method, putting it in standard form, we'd get x squared minus 4 equals 0. Now, this is the difference of squares, and that would factor into its conjugates, x plus 2, x minus 2. So here we would have x equals a negative 2, x equals 2. So we get two answers. So as we use the square root property, and we're going to take the square root of this now, and the square root of that, to be sure we get both answers, we have to use the plus or minus the square root of 4. For example 1, in your notes, we'll go to our whiteboard. So here we have our basic equation, and we want to isolate the x squared. So we're going to divide both sides by 3, and we then get x squared equals 17. Now when we take the square root of this side and then plus or minus the square root of this side, we get x equals plus or minus the square root of 17. So this is another way to solve quadratic equations. All right, let's go to our whiteboard, from our whiteboard back, and we see there is our answers down below. Now, for example 2, we have this item, and take a moment to write it out, and we'll go to the whiteboard. And you see what we have here is a modification of an item that's squared equals something, and in using the square root property, let's write it again, x plus 4, the quantity squared equals 21. We're going to take the square root of this side and then plus or minus the square root of that side. Again, this is the square root property. Now, an interesting thing happens when you have like a binomial that's squared and has a single term because of the parentheses. And remember, our index number is 2. Well, when you're taking the square root of something that's raised to the second power, it just becomes the radicand. So now, to solve it, get x by itself, you just transpose the positive 4 to the other side, and this becomes a negative 4 plus or minus the square root of 21. So a very useful tool in doing this kind of problem when it's a binomial that's squared. Now, there's a lot of background information here that we're not going to cover in this course, but just know this procedure. We'll go back to our regular board, and we see the answers are there. All right, let's go on. Plus or minus in the software, and that would be acceptable. All right, let's go on. Now, in this next example, example 3, in your notes, we're going to use one of the techniques we just had in the previous chapter as we go to our whiteboard. Now we're going to take the square root of this side and then plus or minus the square root of that side. This just becomes the radicand, and this becomes plus or minus. Now notice what's happening here. 50 is not in its simplified form. We can take out the factor 2 times 25, where 25 is a perfect square, and then the 2 is what's left over, our last lesson. So this will become x minus 2 plus or minus 5, the square root of 2. Now we've simplified this radical, transpose the negative 2 over where it becomes a positive 2, and then that is your answer. Wow. So a good little tool in our tool chest for solving quadratic equations. If we had a binomial that's squared equaling something. And we see that down below. Now, for example 4, that you're writing in your notes, we'll go to our whiteboard. And again, we're going to take the square root of this side plus or minus the square root of that side, where this side becomes 2x plus 4, just the radicand. And this is going to become plus or minus. Now, 72 is the square root of 36 times the square root of 2. Sometimes put a dot there to imply multiplication, although you don't need one. And now we simplify this a little bit. 2x plus 4 equals plus or minus 6, the square root of 2. We're going to transpose our 4 over. This becomes a negative 4. We can now take that negative 4 away. And to solve for x, we're going to divide both sides by 2. And you could put it all over 2, or you could put each term over 2. There's a couple of ways to do it. So this gives you x. This is going to be minus 2 plus or minus 3. The square root of 2 is your final answer. And if you had to separate it, you'd have negative 2 plus this, negative 2 minus this. All right, let's take a look at the work here. They're showing it. Now, they're doing it a little different way, but again, we say there's more than one way to do it. You could have put it all over 2, then factored out a 2 from each of these terms, and then cancel it out. the answer comes out the same. Now, if you left it in this stage here, again, they would count that incorrect because you didn't simplify. Just like if you left it in 72 instead of what we illustrated here. Again, you can pause as needed, get some good notes. Now, for example 5, we'll just use what's written here. So take a moment, copy this down. Now, notice what happens when you take your positive 10 and transpose it to the other side. The other side becomes a negative 2. Now, can you take the square root of a negative 2? And the answer is no, because the square root of a negative 2 is not a real number. So keep that in mind as an example when over on the right it becomes a negative value. Those would not be real numbers. Now, is there a solution for this? And the answer is yes, but it's not a real number. It's an imaginary number, and we won't go into that right now. Okay. Now, for example 6, we'll write it out, even though they're just asking for fill-ins here. So starting off, we want to isolate the squared part. So we're going to divide both sides by 4. And then we just get x plus 2. The quantity squared equals 20. Take the square root of this side, plus or minus the square root of 20, and we get x plus 2 equals, now if you recall, 20 was the square root of 4 times the square root of 5, which will become 2 the square root of 5 from a previous lesson, and that's plus or minus. Just transpose the 2 as a negative 2, and then that will be your answer here. So again, a rather useful technique when you have a binomial that's squared equals something. Now for background information, and an interesting thing is, and I will put up here, as we did in a previous video, the letter I in a circle. If you click on this, this is going to indicate how we derive the quadratic formula from the quadratic equation through a process called completing the square. In old days, we would have the students actually charged with knowing how to do that. In this course, we're not doing that. Now, when we set up the quadratic equation, it must be in standard form so that when you pick out values for B, A, and C, it is the values of the A, B, and C when that equation is in its quadratic standard form. Now, that's something we're just going to have, and often on your test and certify, they give you the quadratic formula, and you should have that, of course, in your notes as a reference. Now, an interesting part of the quadratic formula is what is found under the radical sign. B squared minus 4ac. This is given a special term, and include this in your notes. And this is called the discriminant. Now, so if under the radical sign it's positive, then you're going to get 2 real number solutions. If under the radical sign it's a 0, then in a sense there's plus or minus 0. you're only going to get one answer that is, in a sense, repeated. Now, if under the radical sign, after you do your calculations, it's a negative value, remember, that's not going to be a real number, but you're going to get two of these that are not real numbers. And they said, and I'll give you a little hint for future courses, what is this number when the radical is over a negative value? Well, we call these imaginary numbers. So they're not real, but they are a number in our big number system called complex numbers. But we're not doing that in this course. And this is what they're describing. If the discriminant equals 0, there's only one real solution. If the discriminant is greater than 0, there are two real solutions. If the discriminant is less than 0, that is negative, there are no real solutions. All right, so this is our background. And if you have time, watch that video. Now, when we use the quadratic formula, and this is example 7 in your notes, there's a couple of things you have to do as you set it up. Item number 1 is it has to be in standard form. So now we can identify our A term, our B term, and our C term of the quadratic equation in standard form, because that was what was used to get the quadratic formula. So A is 2. Now there's no number there, so it's a 1, and C is a -2. So now we go to substitute. So negative B, negative is in the formula, B is 1, so this is -1 plus or minus the square root now. B squared is 1 squared, which is 1, minus 4 in the formula. A we said was 2. C is a -2. And I would put it in parentheses like this. Now, notice what's happening here. You have a negative in this string and another negative. So this is going to become, and I'm changing it now, to a positive. All right, and this is all over 2a. 2 times 2 is 4. Okay, now we collect the items of our discriminant, and this will be 4 times 2 is 8 times 2 is 16 plus 1 is 17. So this is going to be a -1 plus or minus the square root of 17. And this is all going to be over 4. Now, things to look ahead to is if your discriminant was, let's say, a 20, remember, you'd have to simplify that into the square root of 4 times the square root of 5, which would then be 2 the square root of 5. You couldn't leave it as the 20. Now, I would give you partial credit for that, but again, MathLab would consider it incorrect because you didn't simplify. But here, this is as far as you can go. So let's take a look at it now and clear this up so you can see it. And there it is. Now, again, one answer would be this. And if you put that into your calculator, you would get this value. And the other answer would be this, and it would be this value. Again, you have to, through your practice, know how to put these into Certify and then later your test. Now, for example 8, you're going to write this down, and then we'll go to our whiteboard. Now, there's two ways to do this. I'm going to do it the other way, and you'll see we get the same answers. Now, again, this is not in standard form. So one way is to move everything over to one side, have it equal 0. But then your a term is negative. A general suggestion is if your a term is negative, multiply through by a -1, change all the signs. Now here it's easy because I'm going to just take the a term from this side, move it to the other side, where I get now 3x squared, transposing it from this side to that side, and I'll put the 0 there. And then the other signs stay the same. Now we're going to identify our a as a 3, our b as a -5, and our c as a 1. Now putting this into the quadratic formula, it's x equals a -b. Well, b is -5, so the opposite then of a -5, b becomes a +5. And then plus or minus. Now we're going to square the b. So -5 times -5 is 25. Minus is in the formula. 4 is in the formula. A now is positive as a 3. And c is a +1. Now notice what happens here. Because there's only one negative here, this item under the radical sign is negative. And then this is all going to be over 2 times a, which is 6. All right, we do some work to simplify this. Now this is a -12. -12 and a 25 leaves me with the square root of 13. And this is all over 6. So rather easy. And let's take a look at what they have. Now notice they've moved everything over to the left, which is another way. Your a term is negative. Your b term is positive. Your c term is negative. So when they did all the calculations, they had a negative in the denominator that they had to deal with. And notice that when they finished working the signs here, they get the same thing that we had. And I didn't have to deal with that negative in the denominator, which gets to be a little tricky. So either way is good. I think this way is a little easier. Now, if in the original equation your a term was negative, in future lessons that's going to be critical, but it's not critical right now. All right, let's go on. We're almost finished. Now, for example 9, we've written it here, and you'll write it up in your notes. Let's go to our whiteboard. Now, they've asked us to solve this by the quadratic formula. Keep in mind we could also have done this by dividing both sides, bringing that over, dividing both sides by 2, and using the square root property. But we can also use the quadratic formula. So our a term here is 2. Our b term, you might say, wait a minute, there's no b term. That's right. B term is 0, and your c term is a -25. So putting that into the quadratic formula, it'll be x equals a -b, which is 0. So just to show you that it's there, we'll put a 0. And then plus or minus the square root of b squared, which is 0, minus 4, which is in the formula. A is 2, and c is a -25. And notice we have 2 negatives here, so this will all become a plus. So 4 times 2 is 8. 8 times 25 is 200. and that's all over 2 times 2 is 4. So this is going to be plus or minus the square root of 200 all over 4. Now, we did this one in the previous lesson. This is the square root of 100 times the square root of 2. So the square root of 100 is 10. So this now becomes plus or minus 10, the square root of 2 over 4. But notice you can do some simplification here, that this will become, take a 2 out of there is 2, 2 out of there is 5. So this is 5, the square root of 2 all over 2. And that's plus or minus is your final answer for this one. Now, had we done it the other way, we would have had to use, because we would have had some radical down there, we'd have to use the rationalizing the denominator, but using the quadratic formula, we don't have to do that. All right, let's check it out. And we'll see what we get. And there it is, plus or minus 5, the square root of 2 over 2. And just to show you that again, there it is. So again, we're giving you some models to follow for practice, and then later you're certify. All right, we'll officially skip 10, and we'll go on to something like this, and I'll set this one up for you. Now, notice this is a binomial times a binomial times or equals to 4x. So that's going to be some simplification here, getting rid of our equation and putting it into, and to save a little time, we're going to FOIL this, get that, transpose the 4x, so eventually we end up with 3x squared plus x minus 2 equals 0. Okay, and again, we've done the substitution for the quadratic formula, so we're not going to do this one, although this is an interesting results here. So let's take a look at this in its whiteboard format. Now, remember, we said we could put our A value in, our B value is 1, our C value is -2 into the quadratic formula. But looking at the answer, interestingly, this could also factor. I think we'll feature that. So this is going to be 3x, and this is going to be an x. Now, we could put the 2 here or the 2 there. If you put it there, this is not going to give you your middle term. But if you put it here, and like so here, a 2 here, and we want a positive and we want a negative there. This actually factors. And when we get our answers equaling each of the factors to 0, this is going to be x equals 2/3, and here x equals a -1. And I just want to show you that in regard to what the solutions are. There's your -1, and there's your positive 2/3. So that can happen out of the quadratic formula. So if you have in the future something you can't factor, you can always now use from your toolkit the quadratic formula, and that'll give you the answer. It just takes a lot of time. And going down a little further, they're showing you it does factor. So anytime in the quadratic formula you get answers that look like this, there's no radicals, then that could have factored. Okay, let's see where we are. And for the sake of time, we're not going to do this one either in any detail. This is example 12. And if you note, this is a perfect square trinomial that they're factoring down below, where you get two of the same answers. And also, when you put it into the quadratic formula, your discriminant is 0. So you get a negative 12 over 8, which reduces to a negative 3 over 2. And you actually get two of the same answers. And here we only list it once. Okay. That will be our lesson, and I think the way it's looking out, they're closer to 30 minutes now, but a lot of stuff to cover. And the nice thing about the flipped classroom, as we're doing it, you can view this again as is needed. Okay, we'll wrap this up.